Finally, today we will deploy a very common manufacturing industrial application as a pick and place using a 2D camera to sense the environment. In particular, we are going to use OpenCV to detect and track where the object to pick is. And we will use inverse kinematic algorithm to allow the end effector of a 6-axis robot to reach the target position and place the object where we want. And stay with me till the end of this video because I'm going to reveal you how manufacturing industries deal with pick and place application for real. This is Learn Robotics with ROS, and in this channel we'll learn together how to program robots using ROS as a framework. We do that by deploying a real robotics application that are used in manufacturing industries. The scope is to allow you to become a robotics software engineer, even if you start from zero. And if you think that is going to be too difficult, well, subscribe to the channel, hit the notification bell, and I can tell you that with this step-by-step approach, you are going to master your career in the field of robotics. So allows me to make a disclaimer here, and this video is gonna be an intermediate level. So if you are a total beginner, I suggest you to look at the previous video in this channel, or if you want to have a faster and structured pathway, check out the course for total beginner in the description down below. And now let's get started. So welcome back in my Katkin workspace. So I'm gonna go through all the package that I have created, and I remember you that there's a specific video for that. So first, Cobot Sim is gonna be the Cobot simulation, and I'm gonna provide the link in the description down below to get the GitHub repository. Then I have this is a Cobot inverse kinematics where I have put all the inverse kinematic algorithm that we have used so far, and something new that we are going to discover in a while. Then what I have here is the OpenCV tutorial package where I have put all the Python code to use the CV bridge function where I remember you that is gonna get the image from image raw topics, and it converts in a type of message that OpenCV can process. I have already done this kind of video, and I'm gonna put the link of this video in the top right corner. And finally, this is the position tracker, which is a service that I have created, and where it composed by this request and this response. Okay, so you already know how to create a service, and if you don't, check out the ROS course for beginners. Okay, here's the situation. So I have already run this code with a depth camera, so I need to run this code again because now we are using a different kind of camera, 2D 2D camera, and where we will need to know if this mask based on color is correct, and we need to get what will be the center that the square of the object will be in the image of OpenCV that is generating, and we are gonna get the width and the height of the object in pixel, and this will be useful for getting the conversion between pixel and millimeter of the object that we wanted to get. So let's run first of all the simulation. So ROS launch, then robots sim, okay, the simulation in Gazebo and RVs is running. So now let's run this string camera pi code, and let's see what the 2D cameras is seeing at the moment. Now, since that we have this camera, we are gonna use this topic. So let's check. Okay, now we have the center of the object that is placed in this position in X and Y. I remember you that this is going to be the direction of the Y, and this is the positive direction from left to right of the X. So save this value here, and you can see here that the width and the length has this pixel. So we can approximate to 27. So this is 27 pixel, and this is 27 pixels as well, or 26, whatever. This is a square, so let's keep 27. Okay, so this information I have used in the GetPosition server. I'm gonna provide the link of this specific video in the top right corner here. And here what we have put is the position of the X in pixel center, in the Y pixel center, that I remember you that is gonna be this one. So X 319 and Y 240. This is, and then we know that the width is gonna be 27, and then we know already, because we have created that the object that you want to pick is the length is gonna be 20 millimeters. Okay, then this is the initial position, and again here we already know what it is because we have a spawner in the specific in a specific point in our environment. And then here what we are going to do is to make this code as a service server. Again, I already done this video. You will find in the top right corner the link to that. And but basically, as a refresher, so this is a server that provides the position of the object in the real coordinates of the environment. So if I run this code, you will see that here there will be the position in x and y related to the environment coordinate. So let's run again to check what happens. So before to do, let's make sure that's okay, this is closed. Okay, let's run it again. Okay. This is the mask. And here we go. Now you can see that the x is going to be 1000 and y 0.10. And if I change the position of this object, let's move, let's take for example here, and here. Okay, let's see what the camera 1 is seeing at the moment. Okay, here we go. We have that the position here, because it says to the top, and the way that we have modified the OpenCV code is in such a way that we have somehow downsized the problem from 3D to 2D, because we have used the color of the top of the object as the threshold of the mask, and then we are gonna have that the position here is gonna be 1023 millimeters in x and minus 96.7 millimeters. Okay, so this is what we have done so far. So now what I'm going to use now is to run a pick and place simple application. Again, here I'm gonna provide the link of the video in the top right corner as a client. So what we have done here, so if we pass through the codes, what we can see here is that we have our main function, and where we are gonna call the pre-pick, the pick, closing gripper and open gripper. But the main difference is that in the pre-pick function, so I have comment out the position, because I want that the server will respond to me with the position that has in the real world. So here in the pre-pick function, I have instantiate a service client object linked to the service GetPosition, that I have instantiated also the service position tracker GetPosition, and then here I raise the request. This is a Boolean type. This is true, meaning that we want the position, and we want that the servers gives the position as a response. And then here, if if we call if we call the service using the client that we have just created, client pose, we are going to save in the pre-pick position the response that the service will give us. And as you can see here, instead of having a fixed value, I will get the value that the camera gives to me, because I have structured the code in such a way. And then all the information about the position of the object that is getting the camera is saved into this object. And then guess what, we are gonna set this position as a set pose tracker, and then we are asked to move using the move function related to the class move group interface. So then I have done the same for the pick function. Basically, it's gonna be the same, with the difference that I have modified the offset here, and then the place will be the same. And then this is gonna be the function close gripper and open gripper that we didn't modify. So let's run this code and see what's happened. So here you can see the servers that is responding with this this value here, and these are the same that we have put in the set target pose. Now we should see that the object is going to, here we go, is going to reach the position. I remember you that this is going to be a real robotics application, because we are going to sense the environment thanks to this 2D camera that is getting the position as a service server, and it stored the position, and as a response it gives this position to the clients. Then in this case the client is gonna be our pick and place application. So now you can see here that the pre-pick position will be something around here, and then he will move in the left side. Now you can see that the grippers is approaching in the right position the object as a pre-pick position. Okay, it has reached the position, and then it's going to approach to the pick position that we have asked to go. Again, I'm gonna use the service server to get this position. Then it seems that has reached the position. Then we close the gripper, and then the object is correctly picked, and we are gonna go to the placed position, as you can see from the simulation, from the simulated environments. Okay, so let's check what is happening to this area, to the place position, to check if we have if the object has reached the target position. So let's create an object camera, and then let's select the topic where this camera is publishing to. And here I remember that it's gonna be Cobot at namespace. This is the name of the camera, and then we're gonna select the image row, that is the topic where this simulated camera is seeing, and it's gonna be in RGB. So this is the streaming image that we are getting from the camera 2 that is placed in the place position. Okay, then as we expected, we are seeing the robots in the camera 2. Again, here for this purpose, I've decided to place in a target position. But if you have some other constraint in this place area, like a godet, a POOC, whatever, you and it is in a fixed position somewhere in this area, you can use OpenCV, for example, to detect where the POOC the POOC of this object is, and then take the center of this POOC and ask with the service server that we have created to get the position of the center of that POOC, and then the pick and place algorithm as a client will ask to the server where the center of the POOC is. So that point will be our new target place position. So this the object has reached the position that we wanted, and then the robot knows that has reached the position, then the gripper are released and are opened. So as promised, now I'm gonna reveal you how the manufacturing industry makes a real industrial application, and basically is nothing more to translate, let's say, this code into a class, and this is gonna be here. So again, here you're gonna find everything in my GitHub repository. And so basically it's gonna be most likely the same, with the exception that we have collected everything in a class, which is a more efficient way to code. So in the main function, we are creating a pick and place object, and then we are going to ask, we're gonna call, let's say, the method from the class that we have created. Okay, so now let's test it. So here you're gonna have the private, where I'm gonna create the geometry message pose object, the quaternion, and the service client object, and the service get position. So feel free to go through all this class. Now what I want to do with you is to test it right away. So now let's test the pick and place simple client class. Before, let's change the position. Now, for example, let's keep it here. We need to spawn the server. Okay, the service was failed because we didn't spawn our service, and now we should go in the place pick position. Okay, is approaching. Okay, it seems that it seems that now the center is not going well, because probably we should do again the mask, but let's see anyway what's happened. Okay, it seems to go to the target position. even if the mask is not set correctly here due to the reflection of the light of the simulated environment, but let's see what's happened anyway. Okay, it seems that despite of the fact that we didn't updated our mask threshold, it has picked the object correctly and then it goes to the placed position. But let's say that it behaves as we expected. We didn't change nothing on our code. We just rearrange the C++ code to the class with the class method. È venuta poca, è venuta. Oh, 2,5. Adesso lo mescolo bene. Ma sei sicura? E poi la metto nel coso, eh? Sì. Poi ti dico io quando ho bisogno di silenzio. Tanto adesso ho finito il video, mi devo solo... No, 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 devo dire l'ultima cosa e poi lo edito. 10 minuti ho finito. Però questa parte taglio l'audio. Devo aspettare che il programma giri. Ma scusami, Fe, ma se non ci dobbiamo aggiungere niente, io lo metto direttamente nel Termos e lo mescolo nel Termos. Okay, the robot is approaching the place position as we wanted. Okay, the application has been completed. So that's all for this video. I hope that you enjoyed it. If you like this video and you want to learn more about being a robotic software engineering using this practical approach, don't forget to subscribe to the channel, hit the notification bell, and put some comment down below if you think that this approach has been useful for your industrial application at your work or in your studies, whatever it is. So again, thanks for your attention and keep learning robotics with ROS.